So my talk is about footpath data and network analysis at the City of Canning. It's a bit of a long story, sort of going over a few years. So before I do that, I'm just going to give a little bit of context. Firstly, who am I? I have an urban planning background, and about 8 years ago, I found the light of GIS and pursued it. And I've been using QGIS ever since. And now I have a very long title of Senior Strategic Planning Spatial Analyst at the City of Canning, which basically means Planning GIS Dude. Now, you might be wondering why a planner is interested in footpaths. Well, as a bit of context, if you look at some of the contemporary planning documentation, walkability is quite a big thing. So this is a screenshot from Liberal Neighbourhoods where I was searching for the word walkable, and it was in there 47 times. Alternatively, if you look at the R codes, the newer versus the older R codes, you can start to see the difference in terminology here, where we've got measurements in straight lines going to walkable catchments. So that's why I guess an urban planner might be interested. So this all began, it was 2018. QGIS 218 was the stable release, if any of you remember that one. And we were having some discussions in our strategic planning team about having that rapid walkability analysis in the GIS. It didn't look that easy to me back then. And I thought I was probably in for a few months worth of tutorials and online searching. But then we got QGIS 3, and it had the network analysis tools in there. So of course, like a kid in a candy store, I grabbed our road centerline data, and I threw it at those algorithms, and we end up with something that looks like that. So this is a high school out in Parkwood. The yellow points representing the entrances to the school, and the blue lines are a 400-meter distance along the road center lines out from those points. And they all overlap each other to form like a collective catchment. So we started using more and more of this analysis as we were going through. But I quickly realized that roads don't really equal paths. Because you see, paths go through parks and pedestrian access ways, which means they can actually have a different catchment. And on the flip side, you've got roads like this, where I don't think you can walk. And so I quickly realized I needed the footpath data in order to do this really accurately. And that's where the problem started, because it was out of date. I know, I was shocked as well. There was no crossing lines to connect the paths, so when you get to an intersection, they just end. There's just a big gap, so you can't do the network analysis. And then geometry was a bit rough, so this was a picture of what it kind of looked like. And as you can see, the path lines, in some cases, are a bit of an abstract representation of what was out there. So I decided I cared enough, and maybe I was just young and naive, and decided I was going to rebuild this whole data set. And so I did. So we needed new center lines. GIS also asked me to do polygons, and I said, sure. A bit foolish, but sure. And importantly, we needed the line data to be really accurate. So the new data was going to have a whole bunch of attributes, but the most important one was the type attribute, at least for my analysis. And in here, we were going to put in a few things. So one was for footpath. The second was for shared paths. These are paths that are normally 2.5 meters in width or wider. Shared path, not standard, is the ones that should be 2.5 meters, but were probably constructed way back when 2 meters was appropriate. Cross for crossings, so these are like signalized intersections, zebra crossings, those sort of things. IPA was informal pedestrian access, think verges where there's no path, and I'll get to those in a second. IPA cross, so these were informal crossings, so it's a crossing across the road, but you've got no protection whatsoever. And the last one, which was added a bit later, was a drive cross. Now this one was for mostly commercial and industrial areas where we have really wide crossovers that cut footpaths into segments, so we had to create crossing lines for those. So the process, I started by creating a grid over the City of Canning, and I started at the north and worked back and forth like an old school printer, working my way down. I created the polygons first, and you might be asking why I didn't do the lines at the same time, because I very quickly realized I was in for a long haul and I wanted to win, so I got them done first. And then I came back to the center lines. So the polygons were easy, but pretty time consuming. Luckily for me, we had a work experience student in our GIS team who did a lot of the centre lines for the north of the Canning River, which was great. So all I had to do was fix them up and put in all the crossings and so on. But then I got to south of the river, and there was no such luck, and that kind of sucked. So I went looking for something, and I found the toroidal axis algorithm, which is in the geosimplifications plugin for QGIS. And what it does is it uses triangulation to create a skeleton in a polygon, which in the case of the footpath polygons happen to be basically the center line. It's great for the most part, but complex geometry does confuse it a bit. So you get these sort of squiggly, zaggy lines. But it was still a massive time saver. So all up, the whole recreating the data, this is about a 3-year process. And bear in mind, I had other work as well. This was used a lot. And I needed to go here a few times. But we got to the end result, which was 2,647 current polygons in our data, 7,337 current lines, including all your crossings and verge lines and so on. And we finally have a fairly up-to-date network, which is great. If we come back to that school that I brought up before, you can see in orange what the difference is. And I've circled them just in case. But of course, the data's got more rich information in there that we can use. So I'm going to use a different school, for example. Take Bannister Creek Primary School and Linwood. If we run the whole network of 400 meters, we get these red lines. But if we filter out those verges, we get the blue lines. And I'm guessing people can quickly see where there's gaps in the footpath network. And then if we take out those informal crossings, we get the orange lines. And then we can start to see where there may be an unsafe crossing for kids. So I generate these walkable catchments from a number of facilities, whether they be schools, shopping centres, bus stops, train stations, right? And there's probably about 20 layers that get spat out. And I decided that doing these by hand each time I updated the footpath data really sucks. So I automated it by using the QGIS graphical model. So this has, each of these steps is basically just it pumping out a new walkable catchment based on different filtering. And I go away and have a cup of tea and come back 15 minutes later and it's done. So being in the planning team, what's the planning use case? Well, for starters, we would like to know where we should increase densities. So having walkable catchment, access to bus stops, train stations, that sort of stuff is important. Our stat planners, when they're assessing development applications, also will look at, will they consider a parking shortfall if it's within walking catchment of a train station, for example. We can also look at where there's gaps in access to parks. And I'm plugging it into some multi-criteria analysis as well at the moment, which is quite fun. So some limitations. QGIS couldn't actually filter the network, i.e. the footpath network, which would basically mean having multiple copies of the data, which I didn't really like. So we contacted our friends at North Road, and they implemented the ability to do expression-based filtering in the network analysis tools. But they went a bit further and actually implemented it for pretty much all vector tools. So you can actually do the filtering, even on your buffers and that sort of stuff. The second limitation that I run into is the point-to-network jump. So the algorithm actually will take a point and it'll use the line layers, obviously. But if the point does not connect with the line, it'll just jump over to the line. And that can be a really long distance. And it doesn't add this to the jump distance. So in that example I had there with that bus stop, this is what the walkable catchment looks like for that bus stop. If we look at 400 meters or 250 meters, it's just that red line on the other side of those industrial properties, which is not right. So again, we contacted North Road, and they put in an advanced parameter where you can limit how far the point to line jump can be, and that came in QGIS 338. And any points that fall outside of that can also be exported as a separate layer. So this is the same analysis, but with a 20-meter cutoff, and you can see there's an error up there which says, sorry, your point's outside of what you specified. All our data's on our open data portal. It's on Data WA as well, and synced from our database once a week. So if you wanted to play around with it, feel free to. As part of this, we also need to sync our data back to the asset system because we need asset IDs assigned. And they need to be advised of when there's a new path, a modified path, or a deleted path. and I decided I wasn't going to copy things by hand, so I used query layers in QGIS to do that. If you don't know what query layers are, they're basically a bit of SQL code that can get loaded into your QGIS project as a separate layer. So the top one there is for new paths. It's just basically looking for a null asset ID field. And then the bottom two are looking for modified and deleted paths based on if there's a date in a VT mod or VTN field. And you end up with something that looks like this, where the orange polygons there are, previous footpaths that were now being deleted, and the blue lines are ones that they've been modified, so they might have been cut back a bit to allow for new construction. What I would do differently, if I was doing this again, I'd probably have some sort of rating system for our crossings. If you have a look at that image up there, there's actually two crossings across High Road there. There's one at the signals, and then there's one sort of to the right, sort of going through a median island. They both have the exact same attribute, but one could actually be a safer crossing than the other. So having a rating would be, a bit better for a more granular analysis. And in terms of future work, obviously update the data as it comes, but also probably build out from our boundary by about 800 meters, maybe a kilometer. Because what we find is we end up with other LGAs that have got facilities that are right on our boundary or fairly close to, and we can't capture their facilities in our walkable catchments because we don't have that sort of network built out. So that's something I'd like to do one day if I ever get the time. And that is it.